Okay, so that's done. We go and refresh this. You can see that we've got our output. We go and take a look at our video. That is our grayscale video effectively now gone and rendered out, all cinematic and whatnot. And if you want to go and produce a grayscale hackathon video, there you go. This is how to do it. What's happening, guys? Welcome to another episode of the OpenCV Basics series. My name is Nicholas Renault, and in this video, we're going to be focused on how to work with video. So if you've seen any tutorials on OpenCV before, you probably know that it's really good at working with different types of images. So what do we do when it comes to working with video? Well, in this tutorial, we're going to be focused on exactly that and taking a bit of a deep dive as to how to actually work with video using OpenCV and Python. Let's take a deep look as to what we'll be going through. So what is it that we're going to be covering in this tutorial? Well, as I was saying, OpenCV is great for working with images. So what do we do when it comes to working with video? Well, what you'll actually notice in this tutorial is that it works very much the same way. We just need to do a couple of additional pre-processing steps or a couple of additional steps to be able to work with video. Now, in this tutorial, we're going to be focused on three key things. We are going to take a look at how we can access videos using OpenCV. We'll also see how we can render them to the screen in real time. We'll take a look at how to interpret the output, because I think this is really important, and it's what differentiates videos from images when it comes to computer vision. We'll also take a look at how we can write out our transformed video, something which is ridiculously important. Namely, because typically when you're doing computer vision tasks, you might perform some augmentation, some transformation, you might even apply some visualization to your videos. So you want to be able to output the transformed output to a video so that you can actually see that later on. And maybe you want to share it with somebody. That's exactly how you might go about doing it. That's pretty much what we're going to be going through. So ready to do it? Let's get to it. Alrighty guys, so welcome to the tutorial. So in this tutorial, we're going to be doing 5 key things. Now, I started recording this tutorial and realized it was way too high level. There was a bunch of details missing. So I actually went back through, rewrote this, and really wanted to delve into the details that you probably need as a developer, because it was killing me that it didn't have enough detail. So here we are. So a more detailed video tutorial for OpenCV. So there's going to be 5 key things that we need to go through. So first up, we need to import our dependencies. We're then going to set up a capture, and I'm going to talk about that a little bit more in the whiteboard session. We're then going to take a look at our capture properties. I'll show you how to play it in real time using OpenCV. And then last but not least, we're going to write out that video. So I'm actually going to show you how to take a video, do some transformations, and then write it out. Super important, particularly when you want to show your results to others. Now, let's jump over to the whiteboard session and take a look as to how to actually work with videos in OpenCV. So the focus of this tutorial is working with videos using OpenCV. Videos with OpenCV. So what is it that makes working with videos so different to how we might go about working with an image? Well, if you cast your mind back to the tutorial where we actually took a look at images, we know that an image is represented as an array. Nope, that's not how you spell array. Also known as a list in Python, right? And really, an image is a 3-dimensional array, typically if you're working with color, and it's going to be in the format of BGR. Should have done this in color, so it's going to be blue, P, G for green, and R for red. So you're actually going to have 3 different color arrays, right? So there'll be a blue one. Let's actually start with the red one first, because that'll go behind. So we'll have a red array. We'll then have a green array. And then right at the front, we're going to have a blue one. So really, an image is just 3 different arrays. Each pixel is going to have the value between 0 to 255, right? So that's what an image is. And we can bring that into our Jupyter Notebook using OpenCV, specifically using the cv2.imread method. So what is it that makes videos so different? Well, if we draw an arrow here and basically say, imagine that this is one image, and that image is represented of these 3 different arrays, so BGR. Well, a video is just multiple frames. So if we take a look, this is going to be a video representation. So each one of these arrays is considered a frame. So what we're actually doing when we're working with videos in OpenCV is we're looping through each one of these frames and we're actually just treating each one of these frames as an image. Now, in order to do that, what we actually do is we first up establish a connection to the video. And this is done using a method called cv2.videoCapture. So think of this as getting a real-time capture feed from that video. Now, what we then do is we actually loop through every single frame within that video, and we access the frame at a point in time. In order to do this, we use a different method called cap, or we actually establish our capture. So this would be called cap. And then what we do is we type in .read, or we use the .read method. And this allows us to get a frame, which is exactly what we had from over here. So we're actually just getting one frame at a point in time. So really, all you're doing when you're working with videos is you're just working with multiple frames instead of a single frame like you would when it comes to working with an image. So it's a slight mindset shift in that you're now working with multiple different types of frames, but really the data transformations that you typically do on an image still apply with a video. Alrighty, back to the code. All right, and we're back. So we've got one main video that we're going to be working with, and it's inside of a folder. Let me zoom in on that. It's inside of a folder called data and then videos, and it's called coders.mp4. It's just a video of a bunch of guys at a hackathon writing some code. So if I actually play that video for you, you can see it's just people coding away, doing some hackathon-y type stuff. Nothing too crazy there. Now, what we're actually going to learn to do is how to actually access a bunch of properties from this video, work with it, and actually play with. This guy's just like scrolling through. He's not actually writing code there. I love that. He's the guy pretending to do work at the hackathon. Look at him. He's just scrolling. He's not actually writing code. Anyway, besides the point. So what we're actually going to do is we're actually going to start out by importing some dependencies. So that is the first thing that we need to do. So let's go on ahead and import those dependencies. So we need 3 dependencies. So we're going to bring in OpenCV. We're going to bring the OS library to make it a little bit easier to work with operating systems, including Mac, Linux, Windows. It's just going to really be for accessing our different file paths and generating those file paths. And then the last thing that we're going to bring in is matplotlib to actually render our capture. So let's go on ahead and bring in these dependencies. Okay, those are our 3 dependencies now imported. So we've gone and written 3 different lines of code there. So first up, I've written import cv2, and this is going to bring in OpenCV. So we're going to be using this a whole bunch throughout this tutorial. Then the next line is import OS. And this is really just going to make it easier to work with different file paths. If you are happy just defining your file path on your operating system, you don't need this. But I've found that when it comes to taking these types of codes and working across different operating systems, it makes your life a ton easier. And then the last dependency is matplotlib. So from matplotlib, import pyplot as PLT. We're mainly going to be using this to render our frame. So this is going to allow us to see the output from our capture. And that is pretty much step 1 now done. So we've imported 3 dependencies. So OpenCV, OS, and matplotlib. Now we are up to step 2, so setting up our capture. So really what we need to do is establish a capture to this coders.mp4 file. So let's actually go on ahead and do this. Okay, that is our capture now done. So let's add a comment there. So set up capture to video. So what I've written is cap equals cv2.videoCapture. So that's from the whiteboard session. Remember, I called out that we're going to use the video capture class to set up a connection to our video. So it's cap equals cv2.videoCapture. And then what we've gone and done is we've gone and passed through the full file path to our video. So this line over here is really just defining our file path. And remember, I said we'd use OS up here to actually do that. So I've written os.path.join. And then I've passed through the 3 different folders, or the path to that actual video. So remember, it's inside of data, and then videos, data, videos, and then our file is named coders.mp4, coders.mp4. So all this is doing is it's giving us our full file path to our video capture class over here. So it makes it a little bit easier whenever you're working with different operating systems as well. Now, if our video was inside of a folder called data, all we needed to do is get rid of our videos folder, and this would give us a new file path. If our video was in our root directory, so the same directory as our Jupyter Notebook or Python script, then we just need to pass through the name of our video. So in this particular case, coders.mp4. But because it's in this folder structure, we need to pass through the full file path, which you can see I've done over here. So the full line is cap equals cv2.video capture, and then to that we've passed through os.path.join, the first folder, which is data, second folder, which is videos, and then the name of the file, coders.mp4. Cool. So that is our capture now gone and created. So what we can now do is we can actually grab a frame from this video capture device. And as we go and grab these frames, we're going to iterate through each one of them. So let's actually grab one frame. Right, so to grab a frame, all we need to do is use the cap.read method. So this is actually going to read through one frame from our video capture. And out of that, what we're going to get is two values. So we're going to get a return value, so whether or not it's been successful or not. So that's the first value here. And the second value is the most important. That is the actual frame from our video. So if I type in frame, this is our set of arrays. Now remember when we were taking a look at the whiteboard session, the only difference between a video and an image is a video is a series of frames. And our frames are going to have three different arrays or three different layers, BGR, blue, green, red. This is what is represented here. So this is one frame from our video capture device. If I go and read this again, that's the second frame, so on and so forth. So we can actually go through and loop through each one of these and play the video. That is what we'll do in, I've gone and collapsed too much. That is what we'll go and do in section 4 when we actually go and play it. But that is a frame from our video, right? So what we can actually do now is we can actually go and render this frame and view it. And this is done using matplotlib. So no different to what we did inside of our image tutorial. So let's actually visualize this rather than just taking a look at the array. We can actually take a look at the shape. So we can see we have the dimensions of 1080 in terms of height, 1920 in terms of width, and 3 channels because it's a because it's a color video. But I'm going to show you how to get some other properties as well. So for now, let's actually go and visualize this. So if I type in plot.imshow and then frame, and then I can type plot.show. So you can see that is a frame from our image. Now in this particular case, we can see it is super blue because we haven't gone and done our color channel conversion that we need to for matplotlib. So let's actually go and do that. So let's just add a comment. So this is going and rendering frame. To change the color, we can type in cv2.cvt color. And then all we need to do is pass through the channel reordering code. So cv2.color equals BGR to RGB. What have I written there? This should be cv2. And you can see that is a frame from our video successfully rendered. So you can see that I've written there plot.imshow cv2.cvt color, and then we've passed our frame, and then cv2.color underscore BGR to RGB. Let me break this down. So this is our base frame. The cv2.cvt color method actually allows us to reorder the color channels, because when OpenCV reads in an image, it's going to read it in the channel order blue, green, red. To work with matplotlib, the imshow method, we need it to be in the format of RGB. So this over here actually allows us to do that color conversion, because you saw that when I didn't have this, you sort of had a huge blue tinge to it. That's because the channel ordering wasn't quite right. By using plot.imshow and then passing through the color conversion or color reordering, this allows us to get the appropriate coloring when we go and show it. The plot.imshow method here basically just gets rid of this line over here. So nothing too fancy. It just makes it look a little bit cleaner. So that's our first capture now set up, and we've actually gone and rendered a frame. So the next thing that we need to do whenever we're working on videos is understand that we need to release that capture. So right now we've sort of got this locked up. So if we were to try to do anything with that video on our disk, we'd probably run into some errors because Python currently has a direct connection to that video capture. So to release the capture, we can type in cap.release. Right, so that is our capture now released. Now, if we were to try to run cap.read again, we wouldn't actually have anything returned back. So you can see it's written false. And that's because we don't have that capture set up anymore. We've actually gone and released it back out into the wild. But that in a nutshell is what you're effectively able to do with videos. But now we've only gone and read one frame, right? So we haven't actually gone and looped through each one of those frames. Because remember, a video is a sequence of frames or a sequence of images. That's really the core difference. So we're actually going to solve that inside of step 4. But before we do that, what we actually want to do is grab some properties from our video. Namely, we want to get how many frames we've actually got to deal with, how many frames per second, because we're going to need that later on to write out our video. And we also want to take a look at the height and the width as well. So I'm just going to show you how to get some properties as well. But on that note, so we've actually gone and now completed step 2. So setting up a capture. So right now I've only just shown you an image. So you're probably thinking, Nick, what the hell? It's just an image. That's not actually the video. Fret not. We're actually going to deal with the whole video in a second. So first up, let's actually go and take a look at some capture properties. So to get capture properties, we first up need to establish a connection back to our capture. So I'm just going to rerun that line up there. And so if I go and run cap.read, we should get stuff again, cap.read. So you can see we're now connected back to our capture device. So let's actually go and take a look at some capture properties. So we can get a bunch of capture properties by typing cap.get, and there's a whole bunch of different properties. So let's actually take a look at a couple of different ones. So let's first up get our height. Okay, so you can see here by typing in cap.get and then cv2.cap_prop_fr, we've actually got a whole bunch of different capture properties here, right? So you can see that there are an absolute ton. Now, I don't tend to use a lot of these. The ones that I typically use are frame count, frame height, frame width. So if we actually typed in frame height, this gives us our height back. So you can see it's 1080.0, exactly the same as what we had when right up here we typed in frame.shape. We can also get the frame width. So let's say we wanted width. We can type in cv2.cap_prop_frame and then width. So that actually gives us our width. So we know that our capture is going to have 1080 pixels high, or is going to be 1080 pixels high by 1920 pixels wide. And we know it's a color image already. So we can also get the number of frames. So get the frames, which is super important when it comes to working with videos, because we're actually just going to loop through each one of those frames to render it. So let's get our frame. So cap.get, again, remember cap.get is going to be your friend. So cv2.cap_prop_frame count is going to be the number of frames. So cv2.cap.prop, that shouldn't be an extra parentheses there. So to get the number of frames, it's cap.get and then cv2.cap_prop_frame_count. So that gives us the number of frames. So you can see here that we've actually got 420 frames within our video. So this means that our video is comprised of 420 different images effectively, right? What was the last thing that we were going to do? We were going to take a look at the number of frames per second. So if I type in cap.get, and this one's a little bit different. So rather than going to frame, we just type in cv2.cap_prop. So you can see here that we've got this. So cv2.cap_prop_fps, that gives us our frames per second. And you can see that we've now got 25 frames per second. So effectively, if we divide 420 divided by 25, that means our video should be about 16.8 seconds in length. If we actually take a look at the length of our video, and we go to details, so we can see our video is actually 16 seconds, right? And that is that calc, right? So pretty cool there. So we're actually able to grab it all using OpenCV. But that in a nutshell is how to get our different capture properties. So remember, to get height, it's cap.get and then cv2.cap_prop_frame_height. So that gives us our height. To get our width, oh God, I've typed in width incorrectly there. So it's cap.get cv2.cap_prop_frame_width. So this is just passing through which property we want from our capture. Then to get the number of frames, cap.get, and then it's cv2.cap_prop_frame_count. Also, guys, all the codes are going to be available in the description below in case you missed something, but it's all going to be available for you to pick this up. And then to get our frames per second, it's cap.get and then cv2.cap_prop_fps. But remember, there's a whole heap of different properties you can get. So cv2.cap_prop. There's a ton, right? So if you wanted codec, if you wanted convert the number of the exposure amount, focus, format, there's a whole ton of stuff, gain, gamma, whole bunch of stuff that you've actually got available here, right?
But more often than not, that I don't actually tend to use a lot of these. The ones that I actually tend to use, I've actually gone through right now. So frame height, frame width, frame count, and frame FPS. And then this down here, I don't think we need that anymore. But there are a ton available, right? But that is how to grab some of the properties from your capture. And remember, you need your capture to be established to go and grab these properties. If I went and released that capture and then went and ran these again, you can see we're going to get 0. That is because our capture is not connected. If we go and reestablish our capture right up here and go and run these again, you can see we're going to get all of our values again. But in this particular case, we're actually going to release our capture because right down here, we're actually going to learn how to actually play a video. So that is step 3, capture properties now done. So what we're going to do is rather than just reading through one frame at a time, we're actually going to play our video now. And I'm going to show you how to do exactly this. So let's go on ahead and do that. Okay, so those are the first 2 lines of code that we need to write in order to render our video. So I've first up established the capture. So this line here is no different to what we had up here, right? Cap equals cv2.video capture, and then I've gone and passed through the full file path to our video. If your file path was different, just plug in the different video there. And then what we're doing is we're looping through each one of our frames. So I've written for frame in, actually this should be frame index. Let's not screw that up. So for frame index in range, and then I've gone and passed through, converted this to an integer. We're just getting back the number of frames. So remember, this property is just going to give us the number of frames. So in this particular case, it's returning 0, but when we actually were hooked up to our frame, we were getting back 420. So we're actually going to loop 420 times and get our frame each and every single time. Now, if I go, we don't need this line over here. So this is actually just going to grab each frame and return its frame index. So frame index. What have we done there? Need 1 more brackets. Let's print this. And what is happening there? So print frame index. Oh, we don't actually have our video capture device. So let's actually paste that up there. Right, so this is actually looping through every single frame that we've actually got within our video. So you can see that there. So what we now need to do is actually go and read our image. So we're going to use cap.read. So ret, comma, frame equals cap.read. And this is going to incrementally go to each frame. So it's going to read that frame. We'll then visualize it. And then when we run cap.read again, it's going to read the next frame. So it's going to iteratively go through every single frame that we've got. So we can run cap.read here. So we're going to say read frame. And then we can actually go and show our image. So we can do that using cv2.imshow. Show image. I don't know why that's tabbing in. cv2.imshow. And then we're going to name a frame. And we're going to call this video player. And then pass through our frame. Okay, let's pause there because I wrote a bunch of stuff that you probably haven't seen before. So I've written, the next line after our loop is I've written ret, comma, frame equals cap.read. So that is no different to what we had over here. So we're just grabbing a single frame at a point in time. Then what I've gone and written is cv2.imshow. And this is going to allow us to show our image inside of a separate box using our Jupyter Notebook. So when I actually go and run this, you're actually going to get a little pop-up at the bottom, which is actually playing our video. So in that particular case, I've written cv2.imshow, and then I've passed through what I want that frame to be called. So it's just called video player, comma, frame. Then all we need to do is we actually just need to shut down that frame. So remember, we're going to run cap.release. Let's go back. And then we're going to run cv2.destroy all windows. All right. So these last 2 lines down here, why is that tabbing? Shocker. All right. So this is going to close down everything. So what's going to happen here is we are going to establish our capture. We're going to loop through every single frame. We're going to read each frame at a point in time. So using cap.read, we're then going to run cv2.imshow to show it to our user. And then we'll run cap.release, which is going to release this if we want to go and run it again. And then cv2.destroy all windows is going to smash down our little pop-up. So if I actually go and run this now, we've got an error. Because we didn't fix this over there. So you can see our pop-up is coming up here and it looks like it's shut down. Let's try running that again. This is our video playing and we've got a bit of an error there. So what's actually gone and happened? Weird. Okay. So we had to add our break out of this to get it to render. Kind of weird there. Okay. So I've just gone and added 2 additional lines of code to get that to work. So I've written if cv2.wait key 10. So this basically gives us time to actually hit a key, and 0xff equals odd q. So this line over here is all to do with actually breaking out of our video or shutting it down successfully. So if I actually go and render this now, so you saw that we got a little pop-up and then it shut, and then we got a little pop-up and it shut. So by adding this break here, we're effectively shutting down our loop. So if I go and run this now, you can see that we are successfully playing our video. And you can see that it's playing each and every single frame. We've got our guy who's fake coding in the corner there. But that effectively allows you to go and render our video. So you can see that was our last 2 lines of code that we needed. So this is actually breaking out of the loop. All right, so let's take a look at what we went and wrote again. So we establish our capture. We then loop through each and every single frame. We then read our frame. We then show it back to our user using cv2.imshow. And then I added this to effectively get our frame capture to work. So if cv2.wait key 10, so this effectively checks to see whether or not we're hitting a key within a certain time interval, and 0xff. So this actually gets what key we actually hit at a point in time. Equals odd q. So basically this loop here effectively checks whether or not you're hitting q on a keyboard. And if you hit q on that keyboard, it's going to break out of that loop. So if I go and run this again, and if I hit q early, it's going to shut down that frame. So if I go and run it again, q is shutting that down. Now, remember that as we're running cap.read, we're actually getting that frame back at a point in time. So if I run plot.imshow, you can see that that is the frame that the video got up to, right? So if we go and run this again, so let's quit it out once we see our fake coder running. Quit. And if we go and render that frame, you can see that that is the last frame that our video got up to. But that, in a nutshell, is really how to work with our video capture. So we're looping through every single frame. We are reading it. We're showing it. And then it's kind of weird that this wasn't playing without this. So if I actually comment this out, you can see we're just getting a gray screen. Might need to look into that. But basically, just throw that in. And in this particular case, it's going to allow us to render our video. So if I go and run this again, video is playing successfully. Now, you're probably thinking, Nick, what? This is great, but I can just play it in like VLC, like nothing crazy there. Well, keep in mind that the whole value proposition of OpenCV is that you can do a bunch of stuff to it, right? So say, for example, we wanted to convert our video to grayscale, right? So let's add a gray transform. So remember, we can go and recolor our image using the cv2.cvt color method. So let's convert it from BGR to gray. So we're going to call it gray. Right, so what I've written there is gray equals cv2.cvt color. I've passed through our frame, which we had from up here, and then I've written cv2.color underscore bgr to gray. So if we now go and pass through gray to our cv2.imshow function, rather than just playing our regular video, we're actually going to be playing a transformed video. So if I go and run this, you can see we're now playing our video in grayscale. Pretty cool, right? So that actually gives you the ability to go and overlay a whole bunch of different transformations. Now, this is particularly powerful when you combine it with your webcam, because you can actually do stuff in real time using your webcam. But that, in a nutshell, is how to actually go and work with those video captures. Now, say, for example, we wanted to take this one step further and actually save our video. Well, how would we actually go about doing that? What I'm going to do is I'm actually going to copy this loop here, and we're going to paste it down here. In order to actually go and save our video out, what we now need to do is go and set up a video writer class. And this will actually allow us to write out each and every single frame as we're playing our video. So let's actually go and start doing this. Okay, so that is a couple of lines of code. I haven't finished this yet because I realized I was going way too fast and I wanted to take a break. So what I've gone and written is, first up, we're getting 3 different properties that we're going to need for our video writer device. So remember, we set up our video capture to actually go and play our video. In order to write out a video, we need a video writer class. Now, in order to set up our video writer class, we're going to need to pass through a number of different properties. So namely, we need to pass through the output path. We need to pass through the codec that we want to use, the number of frames per second, as well as the dimensions of our video. So we're just going to use the same height and width that we had from our video. So we're going to grab that using our capture properties. So remember, to grab height, we can type in cap.get cv2.cap_prop_frame_height. To get our width, we can type in cap.get equals cv2.cap_prop_frame_width. To grab our frames per second, we can type in cap.get equals cv2.cap_prop_fps. All this stuff is what we did right up here. Remember, we've got height, we've got width, then we've got FPS. And that's why I sort of showed you that up there, because we're going to need it to write out our video. So that is grabbing the properties that we need. Then I've started setting up our video writer. So I've written video writer and writer in caps. Again, you could name this whatever you wanted. So it could be underscore. And then I've set that equal to cv2.videowriter in camel case. So this is a cv2 class. So cv2.video. So you can see that when you type in cv2.video, you've got a capture, you've got a writer, and you've got the 4cc. We'll come back to that in a second. This is effectively what's going to be used to actually write out our video. So to that, we're first passing out where we want to output this video. So I'm going to be outputting it inside of a folder called data. And then we don't actually have this set up. Oh, data and then output. And we've got a video there already. So let's actually go and delete that video. So if I go to YouTube and then where are we going? So we're going into OpenCV, data, and then output. So I'm going to delete everything that we've got in there to make sure that we've got a clean folder, right? Empty. And then what we're going to do is we are going to pass through a number of different arguments. So let's actually finish this up and then I'll walk you through it. Okay, that is our video writer device now set up. So the rest of the line, so actually let's just break this up. So these are our properties. And this is our video writer. So the arguments that we're passing through to our video writer device is first up where we want to save our video. So we're going to be saving it inside of a folder called data and then output. So this folder here. Then what we're going and specifying is the codec that we want to use. So for this, I've written cv2.videowriter_4cc. So this just combines these 4 characters together to come up with a codec that we're going to use. Now, if you go to 4cc, what was it? 4cc. There are all of the possible codecs that you can use under here. Now, in this particular case, we're using one called PIM1. So if I type in, if I go to P, and I'll include this link inside of the description below, we are effectively using this codec, right? And there's a specific combo. So this tends to work pretty well to convert it to AVI. So this is the one that I tend to use most, but there's a bunch of others if you do want to take a look into that. So the full line is cv2.videowriter_4cc, and then I pass through P, and then I, and then M, and then 1 to give us this codec over here. Then the last 2 arguments are frames per second, which is this, and a tuple consisting of our height and our width. So this is really just, and I also converted our height and our width to integers. So I just, I cast them to integers over here. So I've written int, and then I've gone and grabbed the property. Right, so that is our video capture class now set up. Now, all that's left to do is actually go and write out each one of these frames. So let's actually go and finish this up, and then you'll see the output. So let's actually go and write out our gray frame. So yeah, let's actually do that. So to write out our video, we just need to type in video_writer.write. And so let's say write out frame. And then you just pass out the frame that you want to write out. So in this case, we're going to let's actually write out our base frame first. So this is just the unedited frame, no data transformations applied. And the last thing that we also need to do is close our video writer device. So close or release video writer. So it's video_writer.release. right? So the last two lines that we wrote there are video_writer.write, and then we pass through what we actually want to write. So in this case, it's just going to be our frame. So really, it's just our image. And then all you need to do is release the video writer device. So video_writer.release. So if we go and run this now, what it should effectively do is go and generate a new video and save it into this folder here. So data/output, and then it should be called output.avi. And again, you could name this whatever you want. It doesn't need to be called output.avi. That's just what I've chosen. So if we go and run this, so in this particular case, we're rendering the gray video, but we're actually going to be writing out the color video. So let's take a look and see if this works. All right, so no errors there. If we go and refresh, you can see that we've got an output.avi video there. So let's actually go and play it. We go into data and then output. We've got a video called output. And it doesn't look like we're getting anything written out there. So let's actually take a look at what's happened. Oh, I've screwed this up. This should be width and then height, not height, width. Let's try that again. Okay, let's see if we've got a video now. Let's take a look at our details. All right, so it looks like we've successfully gone and written some stuff out. If I go and play it, that is our video now output. So the error that we had there is I had height and width mixed up. So it needs to be, what is it, width and then height, not height and then width. But you can see that is writing out successfully. Take a look at that. But right now, you're probably thinking, we've already got that video, Nick. I don't really care. So let's actually go out and change the color, right? And again, you could have a bunch of transformations applied. So like sometimes when I actually go and do like any of the pose estimation stuff, this is super useful because you can actually go and save that video, share it on LinkedIn, Twitter, whatever you want to do. So let's actually go and write out the gray version. So all I need to change is I want to go and save out the gray frame rather than the base frame. So let's actually run this now. So it's playing our video, but it should also be writing out our video at the same time. And it's just going to be called output.avi again. Right, so that's gone and written something out. So if we go and take a look at our video, looks like it's a bit smaller. Looks like we might have errors there. Alrighty, so I went and did a little bit of digging and I worked out why our gray video wasn't outputting. And that is because when we actually go and convert our frame from BGR to gray, what we're actually doing is we're actually cutting down the number of frames as well. So we're losing the fact that we've got 3 channels and we're actually converting it to a single channel image. Now, our video writer device is actually expecting the fact that we're actually passing through a color image. So in order to output this, what we actually need to do is pass through isColor and set it equal to false in order to output a gray image. Now, typically you wouldn't actually be outputting a gray image. You'd be outputting some sort of visualizations on top of the image. That seems to be most often or common use case that I tend to use this for. But if you want to actually go and convert this to gray, you just need to pass through isColor and set that equal to false. Now, again, no other changes. All we've gone and done is changed or applied this additional keyword argument. So if we go and run this now, and let's just double check. So we don't have anything inside of our output folder. If we go and run it, so you can see that this is playing and it looks like it's a little bit slower as well. That's a good indication that it is successfully writing stuff out. Let's let this run. We've got our fake coder here in the corner, just scrolling through, pretending to code. Okay, so that's done. If we go and refresh this, you can see that we've got our output. We go and take a look at our video. That is our grayscale video effectively now gone and rendered out, all cinematic and whatnot. And if you want to go and produce a grayscale hackathon video, there you go. This is how to do it. So in a nutshell, we've now gone and successfully gone and transformed our image and outputted as well. And this is super useful, particularly if you're doing any data visualization or any data transformation and you want to show your results to your users. This sort of pipeline is going to serve you very, very well. But on that note, also, that about wraps up this tutorial. So let's take a quick look at what we did. So first up, what we did is we imported our dependencies. We then went and set up our capture. And remember, you can use cv2.video capture to set up a capture and cap.read to read each frame. We also took a look at how we can get capture properties, how we can actually play videos using OpenCV, and then how we can actually write videos out. And remember, If you want to go and write out a grayscale image, you need to pass through is color equals false. Now, there can be a bunch of errors that happen when you're actually going and writing out videos. So remember, the codec is very, very important to get that right. If you want to use other different file formats, you might also need to change that codec. Very important to note. But on that note, that about does wrap it up.
Thanks so much for tuning in, guys. Hopefully you enjoyed this video. If you did, be sure to give it a big thumbs up, hit subscribe, and tick that bell. Thanks again for tuning into this tutorial. It took me absolutely forever to record the intro. I made so many bloopers, everything was going wrong, but finally got it all together. Thanks again for tuning in, guys. Peace.